السلام عليكم ورحمة الله. دكاترتنا، زملائنا، أحبائنا من كل البلاد العربية، طبتم مساء، مساكم الله بكل خير وبكل ود وبكل حب. نلقاكم مجددا في محاضرتنا الأخيرة لهذا اليوم مع دكتورتنا الجميلة العريقة من المغرب العزيز. تحية لها لقبولها الدعوة، وبارك الله فيها لوجودها معنا في هذا الحدث. كل الشكر لها، جزاها الله كل الخير. الدكتورة وهيبة لقمو من المغرب. تحية طيبة لك يا دكتور، ويحيوك المشاهدين من كل مكان.
شكرا لك دكتور نبراس على الاستضافة. أنا كثير مسرورة بتواجدي معكم. رمضان مبارك للجميع وتقبل الله صيامكم. إن شاء الله حنتطرق اليوم الأندودونتيك ديسنفكشن، ونبدأ المحاضرة إن شاء الله. دكتور نبراس
لا، بنستنوا دقيقة يجتمع بس معنا عدد من الناس، ونبدو بإذن الله في أنشودة دينية صغيرونة، ونبدو على بركة الله. ماشي
إن شاء الله. إن شاء
يلا
الله.
دكاترتنا، اعملوا لنا شير لبعض. خلال دقائق حتبدأ الدكتورة، وحتكون المحاضرة باللغة الإنجليزية بإذن الله.
ساعدني يا رحمن، اشرح صدري قرآن، املأ قلبي قرآن، واسق حياتي قرآن. رحمن رحمن ساعدني يا رحمن، اشرح صدري قرآن، املأ قلبي قرآن، واسق حياتي قرآن. لله لله يهفو آملي، لله ولحفظ كتاب الله، من أول بسم الله للختم وللرضوان. رحمن يا رحمن أنقذني يا رحمن، أصبح ما يدوشو نبني ما يسنسي نوتي يا رحمن يا رحمن ساعدني يا رحمن، اشرح صدري قرآن، املأ قلبي قرآن، واسق حياتي قرآن. يا نور يا نور يا محكم يا تنزيل، لمحمد عن جبريل، من رب العرش دليل، للعالم والإنسان. تكبير تكبير للحافظ وهو صغير، وضاء العين قرير، يحمل فجرا لينير بتلاوته الأكوان. رحمن يا رحمن.
الله أكبر الله أكبر الله أكبر. إن شاء الله ربي يبارك في هذه اللقاءات الجميلة، وإن شاء الله ربي يكتب الأجر في لكل الناس اللي شاركت معنا في هذا الحدث. كل الشكر ليك دكتورتي، نشكرك مجددا لإتاحة هذه الفرصة واستقبال ضيف عربي من المغرب في حدث زي هذا، ولنا كل الفخر بوجود كل الناس والزملاء المغربيين معنا في هذا البث. وبإذن الله نزور المغرب قريبا ونتعرف عليكم قريبا، وإن شاء الله يا رب تجونا وتتعرفوا على بلادنا كذلك. ومن هنا نوجه دعوة لكل الزملاء في المغرب، نحبكم جدا ونتمنوكم أن تزورونا في القريب العاجل. تحية طيبة ليك دكتورة، وليك المساحة تقدر تتوكلي على الله وتبدي في المحاضرة.
إن شاء الله. شكرا دكتور. Good evening to everyone. Today we are going to present the topic of endodontic disinfection. And in our presentation, we're going to talk about how we're going to have an optimal endodontic disinfection. Also, we're going to discuss what are the challenges that we can face in order to disinfect the endodontic root canal space. We're going to see what are the means in order to surpass these difficulties And at the end of the presentation, we will discuss simplified protocol and clinical approaches in order to achieve three-dimensional cleaning. First things first, we need to know that with endodontic therapy, 50 years ago, Professor Schilder, he elaborated some principles for endodontic therapy. And one of the most important principles, and which is the main goal of our therapy, is to eliminate bacteria and protein degradation, and also to maintain this result through time by the total alteration of the root canal space. All that because we don't want to have a recontamination. We want to prevent the recontamination after treatment in time. Successful root canal therapy will depend on multiple factors. It's what we call the endodontic triad, the endodontic trifecta, which is mainly shaping, cleaning, and obturation. It's a trifecta, meaning that each step of this endodontic triad will have direct influence on the other. So, for example, if we don't achieve good cleaning, if we don't achieve a good shaping, a good access cavity, well, even our cleaning step and obturation won't be good. That's why we need to respect the principles of each procedure in this endodontic triad. Endodontic disinfection. Endodontic disinfection is a critical step only because we know that the main goal is to eliminate bacteria. And to eliminate this bacteria, we need the chemomechanical debridement. We can't only depend on mechanical debridement, but also we need chemical agents to help. But in order to achieve this chemomechanical debridement, we will face some intracanal challenges. What are the challenges? It's endodontic anatomy, bacterial flora, and also the presence of the smear layer. Look at the anatomy. This is what we are dealing with. This is the reality. How can we expect that only instruments will clean and shape this endodontic space, which is very complex? In fact, in this study, we can see in the picture here, after they done the instrumentation of the root canal space, the areas that are in green are the areas that were left unprepared, even when they instrumented the whole canal system with files. So in order to improve our disinfection, we need to add chemical agents to achieve a three-dimensional cleaning. Now, what about the bacteriology? There are many bacteria communities in the endodontic space. They are so diverse and they are so rich that we need to think about how to optimize our disinfection so that we eliminate all these bacteria. These bacteria also, they organize in a thick layer attached to the root canal wall. In this thick layer, there is a rich concentration of bacterial cells, which is called the bacterial biofilm. We should also keep in mind that the bacterial diameter is only 0.5 micrometers. It's so small. It's even smaller than canalicals and than dentinal tubules. So it makes it easier for them to penetrate the deepest parts of the endodontic space and to hide in this tubule. Now, we can also see that in the apical third of the canal, there is a specific community of bacteria, which are the most resistant ones and the most virulent ones. This is why, besides the fact that the apical third of the canal is very complex with many ramifications, the fact that we can find morphotypes in the apical canal, it makes that this critical part of the endodontic space very challenging to clean. Now, another challenge that we can face during our endodontic disinfection is the presence of the smear layer. What is the smear layer? So when we are performing our shaping and instrumentation, the instruments, they generate a thick layer that adheres to the canal wall. This layer is like a mud. It attaches very well to the canal walls. It consists of inorganic compounds and dentinal debris, and it also consists of bacterial cells. So it blocks the penetration of irrigants when we are performing our irrigation, and also blocks the adhesion in the face of obturation with the endodontic sealers. So all these points constitute real challenges. We have the endodontic complexity, the diversity of bacteriology, and also its virulence. And not only that, while we are performing our chemomechanical debridement, there's a smear layer that can be generated, which is also a real challenge that we should pay attention to. Now, in front of these challenges, we need to have a plan. And this plan should start by answering these questions. So what kills bacteria and how to reach them all? Let's first answer the question of what kills bacteria. And the answer to this question is intracanal agents. So intracanal agents, they have antibacterial effectiveness, they have antibacterial effect, they are capable of killing bacteria. This is why we need them. In this section, we are going to talk about what are these irrigant agents, what are their interactions, their combinations, and also what's the irrigant activity, meaning how can we improve the effectiveness of our irrigants to make them even stronger to achieve an optimal disinfection. We should not talk about endodontic disinfection if we do not respect some basic prerequisites, like visual aids. If you don't want to miss a canal, if you want to have a correct endodontic access cavity, if you don't want to leave behind an isthmus which is unprepared, and if you don't want to leave some, for example, some carious lesion contaminated areas in the endodontic space, well, you need visual aids. Visual aids are mandatory and so essential for our endodontic therapy, and more specifically for the step of endodontic disinfection. Isolation. I don't think that we need to say more often that isolation is key. Isolation is endodontics. There is no endodontics if there is no rubber dam. You know that you want to kill your bacteria. You want to kill your enemy, so you have to isolate it and then start your chemomechanical debridement safely. Another thing, when we see the picture on the left, you don't want to make a mistake and go right away looking for the apex. No, that's a mistake. You don't want to put your K-file and put it right away into the canal. You are pushing bacteria from the coronal area to the endodontic area and making it even more complex. You have to start with cleaning what you see first. You want to kill the bacteria inside the canal, and you have bacteria in front of you. You have to kill what's in front of you first. Then you can proceed with finishing the preparation of your access cavity and then go on with your disinfection and shaping. And speaking about active cavities, here in this study, it was shown that intracanal disinfection was compromised in the group with conservative endodontic cavities, meaning that when they evaluated conservative endodontic cavities like incisal cavities, like ninja active cavities, well, they had much reduced bacterial reduction than when they used and evaluated conventional endodontic cavities. So to respect and have acceptable and correct active cavity will also impact the outcome of your endodontic disinfection. I think it's very clear that we cannot talk about three-dimensional cleaning if we are not sure about the determination of our working length. And to determine our working length, we need to work with apex locators along with radiographs. They should both work together in order to determine my working length so that I can reach the apical part safely, and I know that I am disinfecting and cleaning the whole endodontic space. Now that we talk about the basic irrigants, the basic principles that we need to follow and respect, like the use of rubber dam, the isolation by using rubber dam, using visual aids, coronal cleaning, and good access cavity. Well, we need to know what are those irrigant agents and how do they work for disinfection. To have an irrigant agent, it should accomplish and fulfill many characteristics. And one of the most important characteristics to have in an endodontic irrigant is to have the capacity to dissolve organic compounds and also to remove the inorganic compounds. It should also be non-toxic and should also allow lubrication. Well, an ideal irrigant agent would have all of these characteristics. But until now, there is no ideal irrigant agent capable of fulfilling all these requirements. Here are some of the frequently recommended endodontic agents for endodontic use, like hydrogen peroxide, sodium hypochlorite, chlorhexidine. We also have the EDTA and citric acid. And the most commonly used are sodium hypochlorite, chlorhexidine, EDTA, and citric acid because they are both chelator agents. They are in the same family, only because they have and they fulfill, each one of them fulfills one of the most important characteristics for irrigant solution. Sodium hypochlorite has been used for so long. This solution appears to be the ideal endodontic solution, only because it has more than one characteristic to be an ideal endodontic irrigant. Sodium hypochlorite is the only solution that has the capacity to dissolve organic matter. It's the only one who can do that. It has great antibacterial effects, and all the evidence and scientific evidence has proven and was strongly in favor to consider sodium hypochlorite as the gold standard and the main endodontic irrigant. But sodium hypochlorite has one limit. This limit is it does not remove the inorganic compound. This is why we are using chelator agents, which are decalcifying agents like EDTA or citric acid, which are capable to remove the smear layer and the inorganic compound. So we said that sodium hypochlorite is the only one capable of the solution of organic compounds, while it cannot remove the inorganic compound. EDTA comes to complete an outset. It comes to complete sodium hypochlorite. It does not come to replace it. They should work together. Although several studies have shown that when we use EDTA as a final rinse in order to remove the smear layer, it's recommended not to use hypochlorite right after because it will induce dentin erosion. So we use NaCl throughout all our endodontic therapy, shaping, during instrumentation, during shaping, during at every step of our endodontic therapy, there should be fresh hypochlorite in our endodontic cavity. So at the end, we need a final rinse, and this final rinse will be with the help of EDTA, because at the final rinse, we have bacteria, and we also have the smear layer that were generated by the instruments we use that NaCl cannot remove. That's why at the end we need to perform a final rinse with EDTA. And as I said, several studies showed that once we use EDTA as a final rinse, you do not have, or it's recommended not to use sodium hypochlorite right after. And this is when chlorhexidine comes in help. So chlorhexidine was introduced in endodontics for its antiseptic quality. And let's pay attention here. We are not talking about chlorhexidine at 0.1 or 0.2%. We are talking about chlorhexidine at 2%, because at this concentration, it's not bacteriostatic, which means that it does not only stop the mechanism of bacteria, but at 2%, it's bactericidal. And what I mean, it kills bacteria, and this is what we are looking for. So chlorhexidine is very important because of three things. First thing is the antibacterial activity. Second, it does not induce dentin erosion like what sodium hypochlorite does after EDTA. So meaning that we can use it as last irrigant after EDTA. And third thing is that it has substantivity. It's actually the only one that has substantivity that could be maintained until 28 days. So imagine when you use chlorhexidine as the last irrigant, you dry the canal, you obturate, chlorhexidine is still performing disinfection. And it shows that it can be maintained 28 days after the treatment, which is very important. This will optimize and achieve a three-dimensional cleaning and ensure a better outcome of our treatment. So to sum up, we know now that there is no ideal irrigant. Every irrigant agent has its qualities and also has its limits. Sodium has qualities and limits. Chlorhexidine also, and EDTA also, meaning that those three irrigants, they should work together. One of them will complete the job of the other. They should work as adjuncts. They should work together. Now, the only problem that we can face is that when we have to use these irrigants together, they interact. And these interactions, they affect negatively our endodontic therapy. One of the most dangerous interactions is the one of sodium hypochlorite with chlorhexidine. When we have a combination of sodium hypochlorite and chlorhexidine, there is a production of a toxic and carcinogenic brown precipitate, which is called the parachloroaniline. This parachloroaniline is very toxic. That's why we should pay attention to this interaction and always rinse with distilled water and dry before moving to the other irrigants. This is a very important step. You want to achieve an optimal disinfection, but you don't want to induce interaction. Now, in front of this interaction, we kept thinking about how can we use these irrigants without having them interacting negatively. And this is where we elaborated some irrigant combinations, like the MTAD. So MTAD is the citric acid that was combined with doxycycline, which is an antibiotic. And the principle of that this antibiotic, it will empower the effect of citric acid, which will make the smear layer removal ability, the inorganic material removal ability even better. So this is a very interesting product to use as a final rinse. Dual rinse. Dual rinse also, this is an interesting product. So researchers have been thinking about elaborating a compatible chelator agent that can work safely with hypochlorite. And this is one of them. Dual rinse is or as we can call it, ethydronate powder. It's a powder, it's a chelator agent that can be used with NaCl, with sodium hypochlorite, and used as one irrigant. They are mixed together, powder and aqueous solution of sodium hypochlorite, and can be used as one single irrigation solution. There's one thing I should mention with this product is that some studies showed that it's a weak decalcifying agent, so they recommended to use it during and after instrumentation, but not as the final irrigant, not as the final rinse. It should not be replaced by EDTA at the end of the treatment. They recommended to use it and then use EDTA as final rinse. This is just to mention this point. There is Q-Mix. Q-Mix is an irrigation solution, which is a mixture of chlorhexidine and EDTA, and it has great antibacterial effects and also a good removal ability of the smear layer. So these combinations are very important, and they are changing the reflection of our endodontic disinfection. And I like this way of seeing things because it will push further our endodontic treatment in global, not only the endodontic disinfection. It will prevent many complications, and it will facilitate our disinfection to ensure better results in time. Now, we're going to talk about the irrigant activity. Irrigant activity, meaning that we want to increase the effectiveness of sodium hypochlorite. We want to make it stronger. So how can we do that? These are the factors that can impact the irrigant activity. We will start with the concentration first. So the concentration of sodium hypochlorite that is commonly used in endodontics ranges from 1% to 5.25%. Sikiera here, in his study, he studied he evaluated the effectiveness of these concentrations on instrumented root canal walls, and the study showed that the higher the sodium hypochlorite concentration is, the larger the zones of inhibition produced. So when we increase the concentration of sodium hypochlorite, we increase the bacterial reduction. But we should not forget, we increase the toxicity too. That's a very interesting point. We increase the toxicity when we increase the concentration. So how can we benefit? How can we benefit from this effectiveness of the high concentration without having to deal with the high toxicity? This is why we're going to talk about volume. So in this study, it shows that a high volume of irrigation and frequent exchanges can compensate for the effects of the concentration. A high volume of irrigation and the frequent exchanges can compensate for the effects of the concentration, meaning that we can enjoy the effectiveness of low concentration only by adding more volume. We can have the same effectiveness of low concentration with high volume as when we use high concentration. And we're going to benefit with more safety. We're not going to have a high toxicity, but we're going to have low toxicity and more effectiveness. We should also use this high volume with frequent exchanges. And this frequent exchange is what will maintain this antimicrobial effect of the sodium hypochlorite during all the time of our endodontic therapy. So as we saw, we use low concentration, high volume with frequent exchanges. Temperature also is a factor that will impact the irrigant activity. In fact, if we have 2.6% of sodium hypochlorite and we heat it at 37 degrees, its effectiveness is equal to 5.2% at 22 degrees. We benefit from low toxicity, and we ensure high effectiveness of our irrigants. So heating can be done in two methods. It's either we heat the sodium hypochlorite extrabuccally using bottle warmers. It's like what we use to warm milk for babies. We use our syringes and we put it in there to get heated. Or we can heat our sodium hypochlorite inside of the canal by using ultrasonics, or even we can use the heat carrier. And this way, we can ensure a better antibacterial effect. But in heating, we have a little concern that it can damage the periodontal complex. So this raise of temperature can have a negative impact on the periodontal complex. That's why we need to pay attention when we come to use this technique for increasing the effectiveness of our irrigant solution. Now, if we want our irrigant agents to work, we need to give them enough time. We need to give them working time, and this working time should be respected. Well, in several studies and in the literature, they showed that the sodium hypochlorite should be in the endodontic space for at least 30 minutes. At least 30 minutes it should be kept in the endodontic space. 30 minutes is equal of the period and the time of our session. So from the start of our session, from the access cavity, hypochlorite should stay in there until the end of the cavity, just before the obturation, just before using our paper point. We should know that frequent exchanges, as we saw earlier, are very interesting only because the valuable chlorine loses its antibacterial effect every 2 minutes. That's why every 2 minutes we need to use our irrigation needle to exchange, to have always a fresh irrigation in our endodontic act. So now that we answered the first question, what kills bacteria? We saw that we can use irrigant agents. We saw how they can interact. We also saw how to use them safely. When we talked about their interactions and when we talked about the irrigant combination, we also saw how we can improve the effectiveness of our irrigant agents in order to kill these bacteria cells. The other question we're going to answer is how to reach all these bacteria inside our endodontic system. Well, the answer is to optimize contact. We need to optimize contact between our irrigant agents and the bacteria cells, especially the ones that are hiding in the tubules and the deepest parts of our endodontic space. Now, in order to optimize this irrigant contact, we're going to discuss first in this section the delivery means. What are the delivery means? What is the irrigant activation and what are the systems for it? Also, we're going to sum up with clinical approaches, the clinical approach that will help in our endodontic disinfection. So here we have the positive pressure irrigation. Positive pressure irrigation is conventional irrigation. It's basic, it's mandatory, it's what we use all the time. It's a basic step, it's simple. It's when we use our endodontic needle, the syringe. But the only matter and the only limit is that this positive pressure irrigation, when we use it, the endodontic solution, the irrigant solution, does not go beyond 1 millimeter from the tip. So when we are injecting our endodontic irrigants, our irrigant agents, the solution does not go beyond 1 millimeter from the tip of the syringe. It leaves us with the dead zone. This dead zone is the apical part of the canal that cannot be reached with irrigant. We also generate bubbles, air bubbles, and these air bubbles, they sit apically in the canal and they prevent the circulation and also the penetration of our endodontic solution into the apical part, which is known by the phenomenon of vapor lock. So the penetration of our irrigant will depend on the diameter. And the smaller is the diameter of our needle, the better is the penetration of our endodontic irrigation. And we should use at least a 30 G needle in order to reach the most apical part of the root canal, as we saw that this apical part is the most interesting one It's the part that will condition the outcome of our treatments. Generally, when we have failures of our endodontic therapy, it's because of bacteria that were kept in the apical part. This is what causes most of the failures after treatment. So if we want to reach this apical part as efficiently as we can, we need to have a small diameter. And as I said, 30G needle is the diameter which is recommended in literature. I want to say that another point that I want to mention, and this point in this section is do not engage your needle in the apical part from the first start. You have to know that the needle will reach the apical part when there is access to it. And it's the instrumentation, the shaping given to the canal, a taper. This is what will make our needle penetrate and access to the most apical parts that we need. So you are going to reach the apical part when you have done your instrumentation. You instrument and irrigate, but when you have finished your instrumentation, this is when you emphasize the disinfection and cleanage of apical parts, because now it's accessible. It's not only the diameter, but also it's the shape, the design, and the flexibility of our needle. And here, recently, and unlike the conventional metal needle, we can have more flexible endodontic needles, which are very, very practical, like the one that Produit Dentaire elaborated. It's called eReflex. It's an amazing tool. I use it all the time. It's very practical. It bends very well with curvatures, and you know, we're not always dealing with simple, with straight canals. We're not always dealing with straight canals. We always have curvatures. This is when flexible plastic needles they come to help in order to penetrate better to the most apical part of the canal. It's also incredible because, as you can see in the picture, it has markers, of length. So when I introduce my needle, I know exactly what to put it. I want to put it 3 millimeters before the apex. So I have my working length. I measure 3 millimeters before the apex, and I place my needle. I am sure at what length I am. It's safe. It will prevent extrusion. It will prevent accidents. And I really like it, and I really recommend to use these flexible needles. Self-adjusting file. So self-adjusting file is also a mean of delivery. It has continuous irrigation, and it also scrubs the canal wall. So this instrument is very interesting because, as its name indicates, it adjusts and it adapts. It's like a sponge. It adapts to the canal wall. So as far as you are using it, it's scrubbing, it's eliminating debris, and it's also irrigating at the same time, keeping in frequent exchange, keeping it's very interesting because you are scrubbing the canal, you are detaching debris, and at the same time there is this turbulence of flow of irrigation that will make it that will remove it, that will be functioned. That's a very interesting device. Now that we talked about the delivery means, we are going to talk about irrigant activation. And to understand activation, so to activate our irrigants, is to agitate the irrigant in order to facilitate its penetration. So we agitate the irrigant, we create a turbulence of flow, we improve the circulation so that it reaches all the parts of our endodontic system. There are so many different systems and techniques for irrigant activation, like manual agitation, the manual dynamic agitation, like the apical negative pressure, sonic devices. We have ultrasonic devices, the continuous ultrasonic irrigation too. These are all means of activation that we will discuss. We're going to start by the most simple technique. The most simple technique is manual agitation. The manual dynamic agitation is so simple, but yet it is so efficient. And the principle of manual agitation is to use gutta percha and to agitate it manually. That's it. You have hypochlorite inside the canal. You use your gutta percha, you agitate it manually, and this is what is called the manual dynamic agitation. This technique has been studied in so many studies, and it has shown great results. It eliminates debris. It eliminates vapor lock, as we saw. There is no dead zone, and it's simple. We use this technique when we are at the step of our master cone. We completed shaping. We have chosen our master cone. Now, when we want to insert our master cone, I don't think I have to say it again. The endodontic active cavity should always be filled with hypochlorite. It's a reservoir. It should never be empty until when we want to do the obturation. When we are at the phase of obturation, this is when we dry the canal. The canals should remain in constant contact with irrigation during the whole endodontic treatment. So, as we said, we have chosen our master cone. We want to. I prefer to use it when I want to have my X-ray, my master cone X-ray. So when I want to introduce my master cone, I just slowly do some agitation movements. It's vertical up and down motion with my master cone, and that's it. This is the manual agitation that shows impressive results. The apical negative pressure irrigation. So the apical negative pressure irrigation, like this system, ENDOVAC, this is a magnificent system. It consists of two parts. We have a device, a part of the device that injects and delivers. It delivers the endodontic solution in the coronal area, and we have a microsuction cannula. This microsuction cannula is positioned in the most apical part of the canal. Once it's positioned in the most apical part of the canal, it drowns the endodontic irrigant. It drowns the sodium hypochlorite down to it to be suctioned. It's a very empowered technique. This microsuction has a great power. So you need to know that how the sodium hypochlorite comes from up down to this cannula with this speed and this power. It facilitates cleaning, it detaches debris, and also it prevents and it prevents and it becomes more safe to use our endodontic solution without having the risk of extrusion. There is no risk of extrusion in this case. It's a very interesting device. This system and this technique, this principle is called the apical negative pressure. This is EVOC. So EVOC is also an apical negative pressure irrigation system. The only difference between EVOC and ENDOVAC is that EVOC uses also ultrasonic irrigation, ultrasonic activation, while delivering the sodium hypochlorite, while delivering the sodium hypochlorite and functioning it, there is a device that generates ultrasonic energy and ultrasonic waves, so that it activates even more our irrigant solution. This is a new device. I think it's recent. It's not that old. Yeah, it's not. It's very recent, I think, and it's a very promising one. Now we move on to multisonic ultra cleaning system. This multisonic ultra cleaning system, like the gentle wave system, how it works is that the device is placed coronally in the pulse chamber. It fills the tooth, and it delivers sodium hypochlorite, while delivering also and generating also sonic waves. At the same time, there is a continuous irrigation and a generation of sonic waves. And also, not only that, there's a special thing about this system, the gentle wave system, is that the hypochlorite is delivered at 40 degrees. It's delivered at 40 degrees, which empowers and increases the effectiveness of sodium hypochlorite, as we saw earlier regarding the irrigant activity. Now, XP Shaper is also a great instrument that was investigated. Was investigated for endodontic disinfection, and it shows great results. Sonic Flex and Irritate, these are ultrasonic devices. They are passive ultrasonic activation techniques. They generate ultrasonic waves, which generates acoustic streaming. And this acoustic streaming is what will detach the debris and all the bacteria from the endodontic space. One thing that we have to be careful with while using these ultrasonic devices, these passive ultrasonic irrigation systems, is that we need to introduce them and use them in a canal which is well shaped, because we need to how to say it? Never mind. We need to not have this contact between the ultrasonic device with the dentinal walls, because if they touch dentinal walls, it can affect it, and it can also create some ledges, which we do not want that. Now, sonic versus ultrasonic, which is better? To have an answer to this question, this study showed that when they compared sonic activation with ultrasonic activation, they found that there is no significant difference between those two. Those two types of activation, they found that they are similar when it comes to bacterial reduction. So they compared sonic activation with ultrasonic activation regarding bacterial reduction. And they found that there was no significant differences between these two types of activation, right? But ultrasound activation was most effective than sonic activation when they were more specific, when they studied the reduction of Enterococcus faecalis. So when it comes to the eradication of Enterococcus faecalis, ultrasound activation, ultrasonic activation was more effective than sonic activation. And this is very important to know because this bacteria, Enterococcus faecalis, is one of the most resistant bacteria that we can find and which is very implicated in the in periapical lesions and also in cases of failure of our endodontic treatment. So now that we saw how can we deliver our endodontic agent, how can we activate it to create more turbulence and to facilitate its penetration and to reach all these bacteria that can be hidden in the dentinal tubules, as we saw earlier. We saw the different means of it. We should very be careful about extrusion. So extrusion of irrigants and debris is a problem, is an accident that we can encounter during our endodontic disinfection. The conventional needle syringe irrigation extruded significantly more at even smaller apical preparation sizes and produced greater post-operative pain. So the conventional needle syringe was the one that extruded the more irrigants and more debris than other delivery systems and irrigation systems. So the positive pressure irrigation was the one which is more implicated in extrusion of irrigant agents and debris. This is why apical negative pressure is very interesting, as it limits and prevents to have any kind of extrusion at the apical part. Laser. So laser is an amazing device. It's an amazing technology. It's one of the systems that are used for irrigant potentiation. We can have diode laser or erbium laser. Diode laser affects directly the bacterial cells. The energy of diode laser goes directly to bacterial cells and has its effect on it. While erbium laser acts on water. The molecule of water, it goes to water, and we can see it here. It affects water and creates microbubbles. These microbubbles that are generated by the effect of erbium laser on water, they explode. And this explosion is what will cause the cavitation in acoustic streaming. This cavitation in acoustic streaming, it will detach the debris and the smear layer and bacterial cells that are attached to the root canal wall. Now that we talked about all these points regarding our irrigant agents, how to activate them, how to use them, how to prevent their interactions, which comes first, which comes second, and which comes last. We need to have a simplified clinical approach. and we're going to emphasize our irrigation at the end of our treatment. When we finish shaping and we can move on to obturation, this is when we need to have more time and more concentration, because this is the critical step of our endodontic therapy. We shape to clean, and we obturate to keep cleaning in place, to maintain this result in time. So this is the target. This is what we want. This is what we want to achieve. What comes first is only to come to cleaning, and what comes next is only to maintain cleaning in time. So we know that with the advance of instrumentation, we have gained more time during preparation. We are now using rotary instruments, we are now using single file instruments, and we gain more time than before. This time that we gain, we should give it to the cleaning protocol. We should add it to the cleaning protocol. The cleaning protocol should have the longest time of our endodontic therapy. This is to achieve an optimal cleaning and to achieve a three-dimensional cleaning and maintain this result in time to have a successful root canal treatment and have better outcomes. So now many recommendations were elaborated and suggested for the final rinse during disinfection, and this is a simplified irrigation, final irrigation that I can suggest that we can use clearly and with simple techniques. I can say أقل الإيمان is to use this final irrigation. We don't need highly expensive devices. If we can have it, that's good. But أقل الإيمان, this is what we need to use. If we understand what we need to deal with in our endodontic space, so we need to act respecting the principles of this disinfection, of this disinfection process. So after we complete the shaping and we have chosen our master cone, we now can proceed with intracanal disinfection. Let's keep in mind, fresh hypochlorite is mandatory. We always use frequent exchanges. Endodontic access cavity should always be filled with sodium hypochlorite. It's a reservoir. We should maintain these frequent exchanges. We should use our endodontic needles, at least 30 G needles. Better if we use the more flexible ones. At this step, we are going to use sodium hypochlorite for intracanal disinfection. We use manual agitation by the manual dynamic agitation using the master cone, or we use sonic activation. We can use there are different devices in the market, like Endo Activator. It's a sonic device. It's a sonic device that I use all the time, and it's incredible. We can also use the ultrasonic activation. You can use Irritafe, you can use EndoClean, or you can use Evoc. Again, this is an amazing multisonic ultra cleaning system. So after we have used and activated our sodium hypochlorite, we should now attack the smear layer. The smear layer, as we said, it's the layer that sticks to the canal wall and that consists of inorganic compounds. They are dentinal debris, inorganic compounds, and also the organic material from bacterial cells. So for the smear layer, we're going to use chelator agents, decalcifying agents. For chelator agents, we're going to activate them. It's either we use EDTA 17% for 1 to 2 minutes, or citric acid 10%. We're going to use manual, sonic, or ultrasonic activation with our chelator agent. This will have a capacity to remove the smear layer. Always, let's pay attention to the interactions. Before we use this EDTA, we should rinse from hypochlorite and dry the canal, and then inject our chelator agent. Now that we injected our chelator agent and we activated it, we let it sit for 1 to 2 minutes to have an equal time of reaction in order to remove the smear layer. Then we proceed with the irrigation to attack the intratubular disinfection. Now we will go further to disinfect intratubular areas, because we removed the smear layer that was blocking the penetration to these intratubular disinfection. Once we remove this, we need to attack what's inside the tubules. And as we said, we're going to use chlorhexidine. So we use chlorhexidine. It has sustainability, antibacterial effect, and it does not cause any erosion of dentin when it's used after EDTA. So hypochlorite activation. For the smear layer, we use chelator agent as a final rinse. We let it sit to give it time to have its reaction and to remove the inorganic compounds in the smear layer. Irrigation, and then we use chlorhexidine in order to attack the bacterial cells that are in the intratubular, that are in the tubules, the dentinal tubules. Chlorhexidine, with chlorhexidine, it showed that it has very interesting effects when it's used with sonic activation. So chlorhexidine, with chlorhexidine, we use sonic activation. We let it sit for a few minutes, 2 to 3 minutes, and then we dry it. We do not rinse chlorhexidine. We want chlorhexidine to stay deep in the tubules. We want it to stay there in order to work, in order to keep its antibacterial effect in time. So once we dry, this is when we can move on to obturation. And I think with this simplified irrigation technique, this final irrigant technique, we can achieve very interesting outcomes. We can be sure that we have disinfected our whole endodontic system with the means of our irrigant agent, and by the means of activation systems, we can have a very interesting outcome and have indeed our successful root canal therapy. And this is what we can have after this kind of irrigation. This is what we are looking for. We are looking for these specific areas that can be hidden in the endodontic space. We need to see them. We need to fill them with gutta perca and with medication, with endodontic sealers. So with this protocol, we can be sure that we can achieve this result and ensure the endodontic outcome to be better and to have better healing and better results in time. My presentation comes to end, and I thank you very much for your attention. I hope that it was quite helpful and as simple as it can be in order to in order to explain all the characteristics and the steps and principles of this endodontic step, which is very interesting and which is the main goal of all our endodontic tours. Thank you so much.
كل الشكر ليك دكتورة على وجودك معي في هذا الحدث. جزاك الله كل الخير، وتحية طيبة كبيرة ليك ولكل جمهورنا في المغرب الحبيب. مبسوطين جدا بانضمامك لنا يا دكتور، وسامحينا سهرناك معانا وتعبناك، وإن شاء الله يا رب يبقى لك في ميزان حسناتك ويبقى لك بركة ليك في شغلك. أمانة محاضرة أكثر من جميلة، وكل الشكر ليك. حتى تعبناك إنها كانت محاضرة بالإنجليزية بحيث إنها تفيد أغلب الناس، فإحنا آسفين جدا على تأخرناك في هالليل. جزاك الله كل الخير يا دكتور، وبارك الله فيك. دكاترتنا أحبائنا، هيك نقدر نقولوا ختمنا ثالث يوم معنا في الآيدك بإذن الله. ما زال لنا يومين. جرعة معلومات علاج عصب جميلة نتلقوها غدوة بإذن الله. راح يكون معنا 6 سبيكرز من مجموعة دول عربية. فتح رابط التسجيل، فورم التسجيل لأي ناس تحب تسجل حضورها في المحاضرات متاع اليوم، للناس اللي يهمها السيرتيفيكيت. وألقاكم على بركة الله غدا بإذن الله. تحياتي الطيبة وخالص التحايا والحب ليك دكتور وهيبة. موفقة يا رب، ونلقاك على خير بإذن الله.
شكرا لك دكتور نبراس. شكرا.
مع ألف سلامة. السلام عليكم.